So we're going to continue with this series of working with RGB LEDs, and the code that we have written here, we're going to do something so that we can essentially outsource this to its own separate function, to create a color, put it in its own function somewhere so that we can decide how much we want this to run. And so you'll notice this void loop with an open curly brace. This is its own function here. So I'm going to actually create a new function right up here, and I'm going to call it void, which means I'm not going to return anything. Void color maker, and I chose to use a capital M there to distinguish the words. Sometimes we use underscores, sometimes we use what's called camel case, where you capitalize a letter like that. I typically use camel case for my function names. Again, not universal, but that's how I do it. And I'm going to take all of this code that I just wrote here, cut it out of my loop, and put it in Color Maker. Well, that was magical. But it's never going to run. So I'm going to highlight this Color Maker with these open parenthesis, close parenthesis up here, and copy that, and drop that right into the middle of my loop function, right there. And if this all works as I intend, this will change nothing about my code. It will run exactly the same. Instead of going to loop and running my code directly, it will go to loop, call Color Maker, which will do all these things that I programmed into Color Maker, get to the end of the loop, and then call Color Maker again and repeat this, just as it was doing before. So hopefully, if this all works, nothing will change. So it ran this, I look at my board, and it is doing exactly what I expected. Nothing changed. The power of this is that we can do something like Color Maker, delay, and then make another Color Maker. So for example, I can make a color and then have it do something else and then make a different color. One of the first things I want to do is define the parameters in colors so that I don't have to change it in each Color Maker function and make multiple of these. I want to make one and have it apply all the time. So what I'm going to do is I'm going to put the variables right up here in the parentheses. So I'm going to take my int red power, plug it here with a comma, my int green power right after that, and my int blue power right after that. So with commas in between and a space. And all of this, these numbers are going to go away. Where did they go? What we are going to do is we are going to, when we call Color Maker, define each of these in the order they were defined here. So red power, green power, blue power. That means I'm going to go 100, 0, 255 if I want to recreate what I had. I believe that's the order I had them in. And then I'm going to upload this, and hopefully I still will have changed nothing about this code. It will do exactly what it's been doing. Code's uploaded. It is doing the same thing. And so the point is that I could then immediately call something else, like this right after it, where I go full red and full green, and no blue. And if this works, it should go this color, and then go back. It should loop again. So now, by making that simple change, I can define any color by just checking those three in. And if we look at this, we can see nothing interesting happening. Wonder why. My best guess as to why nothing appears to be happening here is because it's happening too fast for us to see. It's happening too fast for us to see. One of the issues with this code is that we don't know how many times each of these is running. Right now it is running only once, and if we take once times hundredths thousandths of a second times 256 loops, 256 out of 100,000th of a second is just not that big. It's still incredibly fast, too fast for our eyes to see. So we need a way to make these functions repeat many times over before going on. But how long they should repeat, It's probably something that we want to decide. We might want to add another variable here called int time. Well, the word time turned orange. That means it's a reserved word. It means something special to the software. So we are going to use something different, such as seconds. There we go. And so that means that we want to define how many seconds that something is going to happen. The tricky part about this is it's going to require some math, but we'll get to that. For now, let's simplify it and call it loops. Int loops. How many times do we want this to loop? So what we're going to do is we're going to put another loop around the loop we have. This time we're going to call it, instead of I, j equals 0. J is less than loops is the point where it's going to stop. We're going to use that loops number that we defined right up here to tell us when to stop, and then j++. Only reason I'm using j is because it's after I. I'm going to take all of this code that I wrote before and I'm going to highlight it and hit tab to make sure that it's spaced nicely, and then tab this over so that this for is in line with this ending brace. It also looks like I missed my intro. Oh, there it is. I've got my intro and closing brace. For this for loop, I have my intro and closing brace, and this is all tabbed in from there. So I want to keep my code neat and easy to read. Now, when I call this function, it's not going to work because I only give it 3 numbers. So let's say I want this function to run 100 times in a loop, and then I want this one to do the same. And let's see how that behaves. You'll notice that I got an error. A function definition is not allowed before this. What I'm thinking happened is I lost a curly brace. Whenever you get an error in this line, look up to the next line with code. Probably the error is up here. I have my void color maker, and that has an open curly, for loop open curly, for loop open curly. I close, I didn't close the function. So there we go. So now I've got that closed. Let's try this again. Nice thing about code is when you make mistakes, it'll tell you. It's not very shy about it. You can now see that my code appears to be doing something interesting. I see these flickering of the different states of how it is behaving. Doesn't seem to be doing exactly what I intended, though. It seems like there's some interesting mixture going on here. All that it was doing is told to repeat this a number of times. Sometimes when things happen too fast, it's easiest to actually extend these out a little bit so that we can say, with this many loops, I'll get to see what's happening. 10,000 loops. Now it should be very slow and easy to see what's going on. I saw it flicker and then shut off. And I don't see any further action. By extending it to 10,000, it's going to take a long time probably before it's going to flicker again. So however the code was written, it flickers and then shuts off. When you start debugging, what you're looking for is things that don't really make sense in the code. So you'll notice up here, I turn all the pins on. At a certain point, I tell them all to turn off. And then I keep looping, but I never told them to turn back on. I want these 3 lines here where I turn the pins on to be inside of this loop here. I can go ahead and tab these over nicely. The point is that I want these pins to be on, then to be shut off at the right time in this loop between 0 and 255. But then when I reset and have it stay on, I want it to turn back on before I turn it back off. I want it to flicker on and off repeatedly, let's say 10,000 times or whatever it might be. So let's crank this back down to maybe something more reasonable, like 1,000, and run a test, because I think this is going to fix the problem. So we look at our circuit here, and now I cannot see anything changing. Oh, there it was. I just changed from full red and full green to some red and blue, and then some red and green. And so I don't know what 1,000 loops is. It appears to be about 5 seconds. Let's count. 1001, 1002, 1003, 1004, 1000. But about 4 seconds, depending on how well you count, how even that was about 1,000 loops. So if I want to change this thing to be seconds instead of loops, it looks like 1,000 loops is 4 seconds. That means each loop is about, or each second is about 250 loops. So if I said seconds, I might want to define a function inside of here that says int loops equals seconds times 250. Is this constant exactly right? Probably not. You'll have to do the math to get that exactly right. But at least for a close approximation right now, that will probably work. Which means that I want to change these numbers to not loops, but seconds. So let's go ahead and say 2 seconds on this one, 4 seconds on this one, and see what happens when we upload it. 1, 1,000, 2, 1,000, 3, 1, 1,000, 2, 1,000, 3, 1,004, 1,000, 1, 1,002, 1,003. Pretty close. If I were to get a timer, we could see how well it actually did. But we just wrote a generic function that will do a certain color for a certain amount of time. You can do as many of these different colors as you want and then have it loop.